All right, so today we're going to be talking about a little bit more than just domain and range. We're going to be talking about end behavior. So end behavior is just another, pretty much an aspect of domain. It's basically what's happening to the y value as you go to either end of the infinities. Okay? That might sound confusing, but it's actually a lot simpler than what it sounds like. So let's look at some examples, and I will show you guys what I mean. So first of all, on this worksheet, this is page 109 and 110. I apologize in advance. There should be arrows at the end of all these lines. So just imagine there's arrows at the end of each line here, because these lines keep going past these graphs. They just got cut off a little bit early. Okay, so first of all, it's going to ask for like the things we already kind of have talked about, the domain and the range. Okay, domain is everything that's happening with your x values, right? So it's just what's happening from left to right. So as you notice, this line's going up and to the left forever and down and to the right forever. So that means that if we keep going to the left forever, the x values are going to keep going left forever too. So the least x value would be negative infinity. Okay? And then the greatest x value is, again, if you squish it down to the x-axis, it's basically going to the right forever, right? Because if we keep going down here, we're still going to the right forever. So it's going, if we keeps going right forever, it's going to go to the positive infinity. Okay, so there's our domain. And just a little heads up, anytime it asks you for end behavior, the domain pretty much has to be negative infinity to infinity, because it's wanting to know what happens to your y values when you go off to the infinite directions on the domain. Okay, range, again, is the opposite of domain. It's talking about what's happening to your y values. So what's happening bottom to top, right? What's happening to your y values? So again, looks like it's going down forever, so the least y value would be negative infinity. And it is also going up forever, so the greatest would be positive infinity. So pretty much the same as the domain, but this is the y value, so it's the y-axis. So negative infinity and positive infinity on the y-axis. Those are different than the x-axis, right? So now we come to our new stuff, the end behavior. So what it's saying is that as x goes to negative infinity, so as we go to the left, basically, we want to look at what's happening to our line. So as we go left, what's happening to our line? It looks like it's going up, right? Up forever. So as x goes to negative infinity, what's happening to our y value? Our y value is going up. And if it keeps going up forever, if x is going to the negative infinity forever, that means y is going to be going up forever, right? So y would be going to positive infinity. And then as we go to the positive infinity on the x-axis, what's happening to my line? It's going down. So as we go more to the positive infinity direction to the right, our y values are getting less and less. And if we go all the way to positive infinity, that means the y value is going to go all the way down to negative infinity. Okay, so that's basically what the end behavior is. It's what's happening to your y value at either end of your left or right spectrum of the graph. Okay, x-intercept, y-intercept, those are where it's crossing the x and y-axis, and it wants the ordered pair, the point. So x-axis looks like it's crossing right here at -1. So it's not just -1 though, right? The point is -1, 0. Because if you're on the x-axis, your y value is 0. And we look at where it's crossing the y-axis, looks like it's crossing right here at -3. But if you're on the y-axis, your x value is 0, so it'd be 0, -3. And those would be your x and y intercepts. And then is it increasing, decreasing? We tell that by going from left to right. What's happening to the line? As we go from left to right, our line is going down, so that is decreasing. Okay? Let's look at another example. Let's look at the vertical line here. So this is, or not vertical, horizontal line. So this is a horizontal line. So domain, if we go to the left forever, it's going to go to negative infinity, right? And if it's going to the right forever, it's going to go to positive infinity. So there's our domain. Range, though, it's a horizontal line. So it doesn't go down, like it's at 5 right now, right? But our y value doesn't ever change if it's horizontal, right? Our y value is going to stay the same. Each point on this line is going to have 5 as the y value. So it doesn't go up or down, it just stays at 5. So this only has one value. So the range is only ever going to be at 5. So that's our answer. It doesn't go up or down. It's not 5 comma 5 because we don't need two 5s if it's the same number. It's the same number. It's just 5. Okay? And then end behavior should be pretty easy here, right? As x goes to negative infinity, what happens to our y value? Well, if it doesn't change at negative infinity, y is still going to be at 5. Okay? And as x goes to positive infinity, again, if it doesn't change, the y value is still going to be at 5 on both those. X-intercept, does it ever cross the x-axis? No, it doesn't. So there is none. No x-intercept. Y-intercept looks like it's crossing right here at 5. So it'll be 0, comma 5. And it is neither increasing or decreasing, so you would just write neither there. And that is end behavior.